Okay, let's start with the basics of application security, often shortened to AppSec. Essentially, it's about safeguarding the software we use every day. It's a broad field that focuses on preventing attacks against applications, whether they're websites, mobile apps, or even embedded systems. We'll look at things like writing secure code, finding vulnerabilities, and testing for weaknesses, all to keep our digital world safe. Okay, let's talk about what an application security engineer actually does. Basically, they're the experts on keeping apps safe. Their main job is finding weaknesses, vulnerabilities, before bad actors can exploit them. That involves things like looking for flaws in code and even staging attacks to see how easily they could be exploited. They work closely with developers to teach secure coding practices, helping to build security into the app from the ground up. They also use tools to automatically check code for problems and assess overall application architecture. Okay, let's talk about how we build secure applications. The software development lifecycle, or SDLC, is basically a roadmap for creating software. It outlines all the steps from starting an idea to delivering the final product. Traditionally, security was often tacked on at the very end as a testing phase, which can be really expensive and lead to vulnerabilities being missed. But there's a better way: secure SDLC or SSDLC. This approach means we proactively think about security throughout every single step of the process, from defining what needs to be built all the way through deployment and maintenance. We'll start with threat modeling to figure out what could go wrong, then design secure systems, write code following best practices, use tools to automatically find vulnerabilities, and continuously test our defenses. It's about building security in, not bolting it on. Okay, let's dive into the OWASP Top 10. It's basically a roadmap for securing web applications. These are 10 of the most critical security risks that developers and engineers need to be aware of. We have injection attacks, where attackers inject malicious code, broken authentication, which means weak login systems, sensitive data exposure when private information isn't properly protected, and so on. Each one has a severity level: high, medium, or low, indicating how likely it is to cause damage. It's all about building a strong foundation for your app security efforts. Okay, let's talk about how we keep users logged in securely, specifically focusing on session management. Think of sessions like a digital keycard to someone's account. We need to make sure that keycard isn't easily copied or stolen. First, when creating a session, it's important to generate really strong, unpredictable ID. Then, where we store those ID matters, encrypted databases are great for this. Don't forget timeouts. If someone doesn't log in for a while, their session should automatically expire. Also, renewing sessions regularly and actively preventing session fixation attacks, where an attacker tricks you into using a known session ID, are super important. Finally, always have a good logout feature that completely wipes the session from your system. Okay, let's talk about how we actually protect user passwords. Storing them in plain text is a recipe for disaster. Anyone who gains access to the database can steal all those passwords. So, hashing is our friend here. It's like scrambling the password into something completely unrecognizable. We use algorithms, formulas that transform the password into a fixed size string. There are a few popular ones: bcrypt, scrypt, and argontwa. Bcrypt is widely used and adapts to hardware improvements to slow down attackers. Scrypt uses a lot of memory, which can be useful on older systems. And then there's argontwa. It's the newest, most secure option recommended by experts, offering strong protection against various attack techniques. Let's talk about API security. It's a really important area for application security engineers. Think of API as the pathways that applications use to communicate with each other, and because they are so fundamental, they are frequently targeted. We'll cover some key concepts like strong authentication using things like JWT tokens and OAuth 2.0, making sure you always validate any input you receive from clients, never trust it. And finally, we'll look at best practices securing your API gateway to handle authentication and rate limiting, following the principle of least privilege when granting permissions, and regularly auditing your API for vulnerabilities through penetration testing. Okay, let's talk about how we ensure users are who they say they are when accessing applications. We're focusing on 3 key protocols: OAuth 2.0, OpenID Connect, and SAML. Essentially, these protocols handle the authentication piece, figuring out who is this user. OAuth 2.0 deals with authorization, letting apps access resources like contacts or calendar events on behalf of a user without needing passwords. OID takes that further by adding information about who the user actually is. It's built on top of OAuth and provides a standardized way to verify identity. Finally, SAML is more commonly used in larger organizations for single sign-on, meaning you can log into multiple applications with one set of credentials. Let's talk about JSON Web Tokens, or JWTs. They are a super popular way to securely share information in web apps, particularly for logging users in and making sure they have access to the right things. Think of them like digital badges that contain claims, basically statements about who you are and what you can do. They're made up of a header, payload, and signature, all designed to keep things secure. But it's important to know that JWT aren't foolproof. There are potential attacks like token theft or even forging signatures if you don't handle them right. So, sticking to best practices, using strong encryption, keeping tokens short-lived, and validating everything carefully on the server side is crucial for maintaining a secure application. Let's talk about cross-origin resource sharing. It's a security feature that lets your web apps safely grab data from other websites, but only if they explicitly allow it. Think of it like a permission gate. The server sends headers along with the resource, telling the browser exactly which origins are allowed to access things. We'll look at some key headers: access control allow origin, which specifies where the data can come from; access control allow methods, letting the browser know what actions are permitted; and access control allow headers if your front-end needs to send specific request headers. Finally, we have access control allow credentials, which handles cookies and other sensitive information. To implement CORS, you'll need to configure your server correctly, usually in your web framework or API setup, and make sure your front-end code is set up with the right options when making requests. Okay, let's talk about how we actually design applications for security. The really important thing to remember is that you want to build in security from the very beginning, not just slap it on at the end. It's much easier and more effective than trying to fix problems after they exist. First, we do threat modeling. This means figuring out what could go wrong with your app and how attackers might try to exploit those weaknesses. Then, we need to follow the principle of least privilege, give users only the access they absolutely require. A layered approach to defense in depth is also critical. Multiple security controls are better than just one. And don't forget about API use secure gateways for protection. Finally, make sure your databases are properly secured with encryption and strong access control. Okay, let's talk about threat modeling. This is a really important step in becoming an application security engineer. It's all about thinking ahead and anticipating what could go wrong with your app. We use different frameworks to help us do this effectively. Stride is a simple checklist that helps us identify common threat types like spoofing, tampering, or even denial of service attacks. Then we can use Dread to score those threats based on how bad they'd be if they happened, things like damage, how easy it would be to exploit them, and how many people might be affected. Finally, there's Linden, which is a privacy-focused model that helps us think about risks related to data processing and user information. Threat modeling isn't a one-time thing. You should revisit it as your application changes. Okay, let's talk about static application security testing, or SAST. Think of it as a really thorough code review done automatically. These tools don't actually run your application. That's the key difference from dynamic testing, but they meticulously examine your source code for potential security problems like SQL injection and cross-site scripting. They use predefined rules to flag these issues, then generate reports detailing what's wrong and how to fix it. SAST is a fantastic way to catch vulnerabilities earlier in the development process, saving you time and money down the road. Okay, let's talk about dynamic application security testing, or DAST. Think of it as a way to trick your app into revealing its weaknesses while it's actually running. Unlike static analysis, which checks the code itself, DAS sends simulated attacks to see how the application responds. It's like sending a few carefully crafted questions to test if there are any hidden problems. It's really useful because you don't need access to the source code, and it catches vulnerabilities that might not be obvious during development. Okay, let's talk about software composition analysis, or SCA. Think of it as a deep dive into the ingredients that make up your applications. We're looking at all those open source libraries and third-party components used in development. Why is this important? Well, vulnerabilities can sneak into these external dependencies, and if they are not found, attackers could exploit them. SCA tools scan for these weaknesses, helping us understand the risks associated with each component. It's a continuous process. We scan, find potential problems, assess the severity, and then figure out how to fix them, whether it's updating those components or finding alternative solutions. Okay, let's talk about securing our containers. The first step is Docker file hardening. Think of this as making your build process super secure. We want to start with the smallest possible base image, like Alpine Linux, to cut down on unnecessary packages and potential vulnerabilities. Then, we'll remove anything that isn't absolutely needed for the app to run. Running processes as a non-root user is another key step. Next up is image scanning. This is where we check our images asterisk before asterisk pushing them anywhere. Tools like Trivy are great free options that quickly find vulnerabilities. Commercial tools like Snike and Enka provide even more powerful features. Regularly scanning your images and fixing any issues you find will greatly improve the security of your applications. Okay, let's talk about keeping your app safe inside Kubernetes. We're going to look at 3 really important areas: RBAC, network policies, and how we manage those sensitive secrets. First up is RBAC. It's like an internal access control system for your cluster, letting you decide who can do what. Then we dive into network policies, which are essentially firewalls for your pods, controlling the flow of traffic. Finally, let's discuss secrets management, protecting things like passwords and API keys. Using a tool like Vault can seriously boost your security there, and remember to rotate the secrets regularly. Okay, let's talk about some specific risks you'll encounter when securing serverless applications. Serverless is fantastic for scaling, but it also introduces a few unique challenges. One big one is function injection, basically vulnerabilities in your code that could allow attackers to run whatever they want. Then there's the API gateway. If it's not properly configured, sensitive data can be exposed. IAM misconfigurations, where roles have too much access, are surprisingly common culprits. Don't forget about third-party dependencies. Either vulnerability in a library you use could open up a whole new attack surface. And finally, keep an eye on event data. Malicious input injected into events can trigger unexpected and potentially harmful behavior. It's all about being aware of these areas and taking proactive steps to mitigate them. Okay, let's talk about secure code review. This is a huge part of being an application security engineer. It's not enough to just fix the bugs that pop up. You need to be proactive. There are several key techniques we can use. First, there's static analysis, which uses tools to scan your code for potential vulnerabilities without actually running it. Then, you have dynamic testing like DAS, where you test a live application by simulating attacks. SAST is similar but looks at the source or compiled code. And of course, manual review is absolutely critical, having a human reviewer look closely at the code to spot anything that might be missed by automated tools. When you're reviewing, focus on things like making sure your inputs are properly validated, handling authentication and authorization correctly, ensuring sessions are secure, and carefully looking at how errors are handled. It's all about thinking like an attacker to find weaknesses before they can be exploited. Remember, security is a team effort. Okay, let's talk about getting security built right into our development process. As an application security engineer in a DevSecOps environment, you're not just fixing vulnerabilities after release, you're stopping them from being introduced in the first place. Think of it like preventative maintenance versus emergency repairs. Tools like SAST and DAST are super helpful for catching problems early on during development before they make their way into production. And we're not just looking at code. Container scanning and even checking our infrastructure as code can uncover hidden risks. By integrating security throughout the CI/CD pipeline, we drastically reduce costs and get a more secure application out to users faster. Okay, let's talk about securing your infrastructure as code. Tools like Terraform and CloudFormation are incredibly powerful for managing cloud resources, but they also introduce risks if we're not careful. Think of it this way: you're defining your entire environment in code, so making sure that code is secure is paramount. Terraform uses HCL, and common problems include things like accidentally giving too much access or leaving secrets out in the open. CloudFormation uses YAML or JSON and can suffer from template drift, which means your infrastructure slowly changes over time without you realizing it, potentially creating security gaps. The good news is there are simple practices we can follow. Always use a secure place to store secrets, only give people what they need to do their jobs, and regularly scan your code for vulnerabilities using specialized tools. Okay, let's talk about keeping your applications safe by managing their dependencies effectively. Think of dependencies as the building blocks of your software. They're what make things work. But those building blocks can also be a weakness if they aren't properly secured. The first step is simply knowing exactly what you're using. So, we need to identify all your dependencies, everything from libraries and frameworks to external API. Then, it's vital to regularly check these components for known vulnerabilities, using tools that automatically scan for problems. Once you find a vulnerability, you want to lock down specific versions of those dependencies. This prevents unexpected updates from introducing new risks. Version control is key here, as is locking down the exact version. Also, be aware of where your dependencies come from. Understanding their origins adds another layer of security. Finally, schedule regular audits and updates to keep everything running smoothly and securely. Okay, so let's dive into the world of third-party libraries, those cool little bits of code that make your app smarter and more functional. But here's a critical point: they aren't always as secure as you might think. Think about it like this: an entire supply chain can be vulnerable if one part isn't properly protected. There are risks, including supply chain attacks, where attackers target vulnerabilities in these libraries to get into your application, or even many others at once. It's really important to understand that many of these libraries come with known vulnerabilities that haven't been patched yet. Managing updates and making sure everything is compatible can be a big job, so let's talk about how we can do it effectively. Okay, let's talk about how we handle vulnerabilities in our applications. It's a crucial part of being an application security engineer. First, we need to find the vulnerabilities. We use tools like SAST and DAST scanners to automatically spot potential problems. Think coding errors or weaknesses in how the app is built. Then, we document everything thoroughly with clear descriptions and what needs to be fixed. Next, it's time for investigation. What's causing this issue? It could be something simple that's easy to fix, or a more complex problem requiring deeper analysis. After understanding the root cause, we get to fix it. That means patching code, updating libraries, or changing settings. Once the fix is in place, we need to make sure it actually worked. That's where verification comes in. We retest to confirm the vulnerability is gone and hasn't created any new ones. This whole process is ongoing. Security isn't a one-time thing. Okay, let's talk about penetration testing. Think of it as a controlled way to see how an attacker would break into your application. It's all about simulating a real attack to find weaknesses before bad guys do. We'll look at different types like black box, where you give the tester no information at all, and white box, where they have everything. And then there's grey box, which is somewhere in between. The main goals are simply finding vulnerabilities, figuring out how risky they are, and making sure any security measures we have actually work. Most importantly, ethical hacking and minimizing disruption to your live system are a priority. Okay, let's talk about security headers. They're like little instructions you give to the browser on how to handle your website. We'll focus on three really important ones today: content security policy, strict transport security, and next content type options. CSP helps stop those nasty cross-site scripting attacks by controlling what resources the browser is allowed to load. HSDS forces the connection to always be secure HTTPS, which prevents someone from intercepting your traffic. And finally, X content type options tells the browser how to handle different file types, preventing it from trying to guess if a file is actually an image or script and potentially opening itself up to vulnerabilities. Let's talk about CORS cross-origin resource sharing. It's a security feature that prevents websites from accessing data on other domains without permission. A really common problem is when servers aren't set up correctly, leading to misconfigurations. These can expose sensitive information or functionality. Think of it like this: the server isn't letting the right people in, usually because the access control allow origin header is set too broadly, like allowing any website to access data. Or maybe the allowed methods aren't listed correctly, or headers aren't properly configured. It's a surprisingly frequent vulnerability that attackers can exploit. Okay, let's talk about certificates and SSL/TLS. As an AppSec engineer, you need to ensure that the connections between your applications and users are secure. That means using the right type of certificate, DV, OF, or AV, based on how much trust you require. It's also super important to keep track of those certificates. Renewals and revocations are vital for ongoing security. And speaking of keys, never ever put them directly in your code. Use a secure storage solution like HSM or Key Vault. Finally, always use the latest TLS versions and strong cipher suites, and make sure PFS is enabled. It's a critical component for maintaining session secrecy. Don't forget to regularly audit your configurations to catch any potential issues. Okay, let's talk about secure file uploads. They're super important because attackers often use them to sneak in malware. The first thing we need to do is rigorous validation. That means checking not just the file extension, but also the actual content type and size limits. Think of it like this: a file named document.exe might look like a document, but it could be hiding something nasty. Once validated, don't just store those files anywhere. Use a secure location with proper access controls. Also, avoid running any code that comes from an uploaded file. It's a huge risk. Best practices include renaming files to make them unique, scanning for malware, and using the principle of least privilege to restrict who can do what with these files. Let's talk about business logic vulnerabilities. They are a really important part of application security. Unlike traditional coding bugs, these issues aren't about the code itself. They're about how users interact with it and how the application handles that interaction. Think of them as flaws in the rules of the game. Common examples include race conditions where multiple users interfere with each other, invalid state transitions that cause the app to act unexpectedly, and IDOs where someone manipulates identifiers to access things they shouldn't. The bottom line: developers need solid input validation, proper authorization, and good state management practices to catch these issues before they become problems. Okay, let's talk about cryptography. It's the foundation of a lot of secure apps. First up, we have symmetric encryption. This uses the same key to both scramble and unscramble data, making it really fast. But this means you need a safe way to share the secret key with everyone involved. Then there's asymmetric encryption, also known as public key cryptography. This uses a pair of keys, a public one for locking things up and a private one for unlocking them. It's slower but offers better security for key exchange. Finally, we have hashing. Hashing is like creating a unique fingerprint of your data. You can use that to make sure it hasn't been tampered with, but you can't get the original data back from the fingerprint. Okay, let's talk about keeping your application safe by managing its keys and secrets. This is really important, because if someone gets hold of these credentials, think database passwords or API access tokens, they can wreak havoc. It's like having a super secure vault for all the things that need protecting. So, first and foremost, you absolutely never want to put secrets directly into your code itself. Instead, We use dedicated secrets management systems, which are basically centralized tools designed to store these sensitive items securely. Tools like Vault or AWS Secrets Manager do a great job of handling this. Then, it's crucial to rotate those keys regularly. Think of it like changing the combination on your lock every few months. And finally, always give services and users only the minimum access they need, the least privilege principle. Alright, let's talk about logging and monitoring. It's absolutely critical for any application security engineer. Think of logs as the breadcrumbs that lead you to understand what's happening in your application. We need to collect a variety of logs, from authentication attempts tracking who's trying to log in and whether they succeed or fail, to WAF logs which capture blocked attacks and potential vulnerabilities. Server logs and database audit trails are also key. And don't forget that everything should be standardized so we can easily search and analyze them later. A good log format is usually JSON-based, something like this. It makes passing the data much easier when you're setting up your monitoring tools. Let's talk about log injection prevention. Basically, hackers try to sneak malicious code into your application logs and then use that information to break in or cause problems. It's all about how carefully you handle user input before it gets logged. The best defense is thorough validation and sanitization of everything coming from the user. Also, always use parameterized queries when dealing with databases to prevent injection attacks. Finally, make sure your logging process only has the permissions it absolutely needs, and keep an eye on things through regular audits and monitoring. Let's talk about protecting your applications from DDoS attacks, specifically those targeting the application layer. These are often more sophisticated than network-level attacks because they mimic legitimate user traffic. We're dealing with things like massive HTTP floods or slow, persistent connections. To combat this, we use techniques like rate limiting to control how many requests a single user can make within a period of time. Web application firewalls analyze incoming traffic and block suspicious patterns, and challenge response systems like CAPTCHAs help differentiate between humans and bots. It's really important to consider the impact on your users when implementing these safeguards. You want to be secure without frustrating legitimate visitors. And finally, constant monitoring and updates are key to staying ahead of evolving threats. Okay, let's talk about web application firewalls, or WAFs. Think of them as a really smart security guard standing in front of your web apps. They examine every incoming request before it even gets to your service. The core is using rule sets, which are like pre-written instructions for spotting common attacks like SQL injection and cross-site scripting. You'll want to keep those signatures updated regularly. Basically, the WAF needs to know what bad looks like. Rate limiting is also key. It prevents things like DDoS attacks by stopping a single source from overwhelming your system. Finally, geolocation filtering can help block traffic that's suspicious based on where it's coming from. Remember, WAF configuration isn't a one-time thing. You need to keep an eye on it and adjust as new threats pop up. Okay, let's talk about securing our mobile apps. We're focusing on the OWASP Mobile Application Security Verification Standard, or MASS. Think of it as a really helpful checklist for developers, a way to systematically identify potential security weaknesses in their apps before they hit the stores. It covers everything from how data is stored securely and protected when being sent over networks, all the way through authentication and authorization, making sure only authorized users can access sensitive information. It's really about building secure coding practices into the app development lifecycle, preventing common issues like injection attacks and ensuring high-quality code. MASS helps protect a huge amount of user data, so it's crucial for any mobile application security engineer. Okay, let's talk about reverse engineering and how we protect apps from being messed with. Basically, reverse engineering means taking apart an application to see exactly how it works under the hood. We can do this by looking at compiled code or even disassembled versions of it. There are two main ways to approach this: static analysis, where you examine the code without actually running it, and dynamic analysis, which involves observing the app while it's running. Now, when it comes to protecting apps from tampering, we use techniques like code obfuscation, which makes the code harder for someone to read, and digital signatures that ensure the application hasn't been altered since it was signed. Finally, there are runtime applications, self-protection systems that monitor the app while it's running and block any suspicious activity. It's a layered approach. No single technique is perfect, but combining them can significantly improve security. Okay, so let's talk about securing our API. The API gateway is often the first point of contact for a lot of traffic, making it a really important place to focus on security. We need to make sure we're verifying who's accessing our services. That's authentication and authorization. We also have to think about preventing overload with rate limiting, carefully checking all input to stop injection attacks, and constantly monitoring for suspicious activity using things like web application firewalls. There are a few common platforms and technologies you'll want to get familiar with to really protect your API effectively. Okay, let's talk about how applications handle errors and potential misconfigurations. This is a critical area for AppSec engineers. We need to look beyond just catching bugs. We're concerned with vulnerabilities that could be exploited. A big issue is often verbose error messages, which can inadvertently reveal sensitive information like database credentials or internal paths. Good logging practices are super important too. Without sufficient logs, it's incredibly difficult to track down and respond to security incidents. Then there are problems with exception handling. If an application doesn't handle exceptions properly, it could lead to denial of service attacks or even allow attackers to inject malicious code. Finally, let's consider security misconfigurations like using default credentials, running unnecessary services, and having overly permissive access controls. The key takeaway here is to implement robust error handling with minimal logging of sensitive details, regularly review your configurations, and always follow the principle of least privilege. Only give users and applications the minimum level of access they need. Okay, let's talk about Content Security Policy, or CSP. Think of it as a strict security card for your website. It controls where resources like scripts and styles can come from. It's a really effective way to protect against XSS attacks. We'll cover some key concepts, like defining allowed sources and using report-only mode for testing. Here's an example of how you might configure the policy in your server headers. It allows scripts and styles from your own site and a trusted CDN. And importantly, remember that CSP needs to be regularly reviewed as your application evolves. Let's talk about CSRF tokens. Basically, a CSRF attack is when someone tricks you into doing something on a website without knowing it. To combat this, we use CSRF tokens. They're like secret codes generated for each user session that are included in forms and requests. The server checks to make sure the token matches what it expects, preventing malicious actors from forging requests. It's an extra layer of security, ensuring only your website can truly initiate actions on your behalf. Okay, let's talk about keeping things secure when you're building a multi-tenant application. Think about it like this. Lots of different customers are sharing the same software. That's great for efficiency, but it means we need to be extra careful about making sure their data stays separate and protected. We've got to focus on isolating tenant data, which often involves clever database techniques like row-level security. Then, you absolutely must cover reliable way of knowing who is accessing what. Don't trust just the browser. Finally, constant monitoring and detailed auditing will help you spot any potential issues before they become major problems. Okay, let's talk about securing your applications in the cloud. The first thing we need to focus on is identity and access management, really making sure only authorized people have access to what they need. Then, it's super important to build security into your development process from the beginning with CI/CD pipelines. We also want to ensure all our data, whether it's stored or being sent around, is properly encrypted. Think about dividing up your network so that if one part gets compromised, it doesn't spread throughout everything. And finally, constant monitoring and logging are crucial. You need to be able to see what's going on and quickly spot any potential problems. Let's talk about building a solid security foundation, specifically creating application security policies and standards. It all starts with understanding the risks you're facing. You need to do a real deep dive into what could go wrong. Then, you start drafting your high-level policies, basically stating what's acceptable and what isn't from a security perspective. Next, it's about translating those policies into clear, actionable standards like detailed coding guidelines or specific rules for how data is handled. Don't forget to document everything thoroughly and communicate it effectively to the whole team. And finally, these policies aren't set in stone. You need to review and update them regularly as threats evolve and technology changes. Okay, so let's talk about compliance. It's a big part of the job for an application security engineer. We're looking at regulations like PCI DSS, which focuses on protecting credit card data and has really strict requirements around encryption and network security. Then there's HIPAA, which is all about safeguarding patient health information, and GDPR, which protects personal data, especially within Europe. These aren't just rules to follow, they are frameworks for building secure applications and maintaining user trust. Okay, let's talk about creating a solid incident response plan for your applications. This step is all about preparation. It's not enough just to react when something goes wrong. You need a detailed strategy in place beforehand. We'll cover the essential components. First, preparation, which means clearly defining who does what and how everyone communicates during an event. Then, detection, setting up tools that can spot potential issues and creating alerts so you're notified quickly. Next is containment, which involves taking immediate steps to stop a problem from spreading. We'll also look at eradication, removing the actual cause of the incident, recovery, restoring your systems back to normal, and finally, a critical post-incident activity phase where we learn from what's happened and improve our plan for the future. Don't forget, regularly testing your plan with simulated incidents is key. A perfectly written document that's never used is completely useless. Okay, let's talk about securing how we build and deploy our applications. It's not enough to just find vulnerabilities after they're released. We need to proactively protect them throughout the entire process. Think of it as shift left, getting security involved from the very beginning. We'll be using automated scanning tools like SAST and DAST integrated into our CI/CD pipeline. Then, we need to secure our infrastructure itself. That means making sure our code definitions for things like Terraform are also protected. Don't forget about container images, they are a common attack vector. And finally, handling secrets securely is absolutely vital. Okay, let's talk about automating security testing within your CI/CD pipelines. It's a game changer because it means we catch vulnerabilities much earlier in the development process before they make it into production. We use different types of tests, like SAST, which looks at your code for problems without actually running it, and DAST, which pretends to be an attacker trying to break in. It's also IAST that combines these techniques. And fuzzing, basically throwing random data at your application to see if it crashes or reveals security flaws. By automating all of this into our pipelines, we can find problems faster, fix them cheaper, and make sure everyone on the team is thinking about security from day one. Okay, let's talk about Git security. It's a really important part of being an AppSec engineer. Think of Git as your code's home base, and like any house, you need to secure it. The most basic thing is to follow the principle of least privilege. Only give developers the access they need, not everything. Also, using short-lived feature branches and frequent merges helps keep things contained if something goes wrong. Code reviews are a must. Get another set of eyes on your code for security checks. And don't forget about your Git hosting service. Use strong passwords, SSH keys, and enable two-factor authentication wherever possible. Finally, regularly check the activity logs to spot any odd behavior. It's a continuous learning process, so stay sharp. Okay, let's talk about how we break down our application environments. Think of it like building a castle. You need different zones for different purposes. Development is where the builders create and play around, so security isn't as strict. But testing is when we really put all the defenses up to make sure everything works securely. And then there's production, which is the final, live version, and that needs the most robust protection in place. Okay, let's talk about minimizing risk specifically with something called principle of least privilege. Basically, we want our applications and their components to have only the permissions they absolutely need to do their job. It's like giving someone a key only to access the rooms they should be in. It drastically reduces how much damage an attacker can cause if they manage to break in. This isn't just good practice, it's often legally required. We can use techniques like role-based access control or attribute-based access control to really enforce this idea and make our applications significantly more secure. Okay, let's talk about Rust runtime application self-protection. It's a really clever security technique that works inside your application, unlike traditional firewalls which sit at the edge. Basically, Rust constantly watches how your app is behaving and flags any suspicious activity, like potential attacks or vulnerabilities being exploited in real time. Instead of just stopping an attack, it can even dynamically change things like rewriting code or blocking a malicious request before serious damage happens. It's like having a security guard specifically looking out for threats within your application, making it significantly more resilient. Okay, let's talk about data protection and privacy. It's a really important part of being an application security engineer. Basically, we want to make sure we're only collecting what we need using it for the purpose we said we would, keeping it around only as long as necessary, and making absolutely certain that it's accurate. And, of course, protecting it with top-notch security measures like encryption. From a development standpoint, this means building apps that are designed to minimize data collection upfront, and then implementing secure ways to store and handle that data, giving users control over their information whenever possible. Okay, let's talk about how we control who gets access to what inside an application. We use something called access control models, basically rules for granting permissions. First up is RBAC, or role-based access control. With RBAC, users are assigned roles, like administrator or editor, and each role comes with a set of predefined permissions. It's great when you have lots of users who need similar access rights. Next we have ABAC, attribute-based access control. This is more flexible. It looks at things like the user's department, the type of resource they're trying to access, or even the time of day to make an access decision. Finally, there's PBAC, which combines elements of RBAC and ABAC, using policies a good balance between control and flexibility. Okay, let's talk about keeping data safe both when it's sitting quietly and when it's on the move. First up is encryption at rest. This basically means securing your data wherever it's stored, like in databases or backups. A really popular method here is AES Advanced Encryption Standard. It's a robust way to protect against things like physical theft or access from someone who shouldn't have it. Now, when data needs to travel across the internet, think of your website or app talking to a server. We need encryption in transit. TLS/SSL is the industry standard for this. It ensures that the information isn't intercepted or tampered with during its journey. Think HTTPS, that's usually what you see at the beginning of a secure website address. Okay, let's talk about some common client-side security threats. First up is DOM-based XSS. This isn't about the server sending you a malicious script, it's about how your browser interprets code *** to the page. Imagine a form where users can enter text. If the text is directly inserted into an HTML element without proper cleaning, a hacker could inject malicious JavaScript and run it on your machine. It's like a sneaky trick. Then there's click checking, which is even more subtle. This involves layering deceptive content over legitimate websites to trick you into clicking things you didn't intend to. Think of it as an invisible overlay trying to pull the wool over your eyes. We can prevent these attacks with techniques like frame busting and setting a specific header on our servers. Let me know if you'd like to dive deeper into any of these. Okay, let's talk about keeping SPA and PWA secure. These apps can be tricky because they run mostly in the browser, so we need to think differently about how attacks happen. XSS is still a big one, where someone injects malicious scripts through user input, but there are other vulnerabilities too, like client-side injection and issues with caching. A good starting point is always using content security policy. It's like telling the browser what resources are safe to load. And don't forget about SRE, which helps us make sure those third-party scripts haven't been tampered with. Finally, carefully controlling core settings can prevent unauthorized access to data. Okay, let's talk about API abuse and how we can protect ourselves. API are everywhere these days, and unfortunately, they are often targets for attackers. We've got things like denial of service attacks, where someone floods your server with requests until it crashes, brute force attempts to guess passwords or credentials, and even data scraping, grabbing huge amounts of information without permission. Rate limiting is a really important tool to combat these issues. Basically, it's putting limits on how many times someone can call an API endpoint in a certain period of time. Think of it like a traffic cop for your API. We use techniques like the token bucket or leaky bucket algorithms to make sure we're not overloaded. Let's talk about broken access controls, a really common security risk. Basically, it happens when applications don't do a good enough job of making sure only authorized people can see and use things. We often see this through things like IDOR attacks, where users trick the system into giving them access to stuff they shouldn't have, or privilege escalation, where someone with basic rights suddenly gets super powerful. To fix this, we need strong authorization checks, using tokens for security, and always following the principle of least privilege, only give people what they need. And finally, regular audits are key to catching these issues before they cause problems. Okay, so let's talk about getting developers on board with security. A lot of vulnerabilities actually start right in the code itself. That's why it's so important to make sure everyone understands basic security concepts. We're going to cover some common problems like injection attacks and cross-site scripting, which are huge risks. It's all about building good habits from the beginning, always validating user input, using secure ways to store secrets, and getting your code reviewed by others. And crucially, security is an ongoing process. You need to keep learning as new threats pop up. I'll link some helpful resources below where you can dive deeper. Let's talk about managing a bug bounty program. It's more than just throwing up a sign saying we pay for bugs first. You need to clearly define what your program covers and set very specific rules about what researchers can and can't do. Then, create a tiered reward system where the most critical vulnerabilities earn the biggest payouts, and consider using a platform like HackerOne or Booker to help manage submissions. You'll also want to actively recruit skilled researchers, make sure they understand your guidelines, and keep them in the loop with updates on reported issues and remediation efforts. Good communication is key. Let's talk about vulnerability disclosure programs, or VDPs. Think of them as a way for security researchers to safely help you find and fix vulnerabilities in your applications before malicious actors do. A good VDP has a clear policy explaining what types of issues are accepted, makes it super easy to report them, and keeps reporters informed about how their reports are being handled, whether that's through rewards or just the satisfaction of knowing they've helped improve security. There are different kinds too, like bug bounty programs where researchers get paid for finding bugs, or open disclosure programs where you simply welcome vulnerability reports without specific incentives. Okay, let's talk about something really valuable in building a strong security posture: security champions. Think of them as enthusiastic advocates for security within your organization. They aren't replacements for dedicated security teams, but vital allies. They're volunteer employees who step up to educate their colleagues, spot potential vulnerabilities early on, and promote secure behaviors like using strong passwords or being wary of phishing emails. Their roles are varied, raising awareness about common threats, participating in bug bounty programs, and even acting as a feedback loop for the security team, passing along any concerns they identify. Essentially, security champions help create a culture where everyone understands that security is everyone's responsibility. Okay, let's talk about building in security from the ground up. A key part of this role is setting up code quality gates within your development process. These are essentially automated checks that fire at different points during development, like before you merge code or before it goes live. They're designed to catch potential vulnerabilities early on, not after they've made their way into production. We can think about them as checkpoints, making sure the code meets certain security standards. There are several types. Static analysis tools scan your code for issues without actually running it, Dynamic analysis checks the application while it's running, and dependency scanning looks at all the external libraries you're using to see if they have known vulnerabilities. By consistently enforcing these gates, you drastically reduce the risk of security problems making their way into your applications. Let's talk about securing your containers, specifically within Kubernetes. Think of Kubernetes as a massive, complex machine. It's incredibly powerful, but requires careful attention to security. One of the biggest challenges is that namespaces aren't always naturally isolated. You need to actively build in layers of protection. We'll cover some key areas like network policies, RBAC for managing access, and making sure your container images themselves are secure. Finally, if you're using a service mesh, remember that securing the control plane is absolutely vital. Okay, let's talk about securing applications in the cloud. Specifically, we're focusing on how identity and access management, policies, and secrets management fit into the picture. Think of IAM as your central control panel for who gets to do what within your cloud environment. It's all about giving the right people the right access. Policies are like a set of rules that dictate how your applications are built and run, often through infrastructure as code tools. And finally, secrets management is crucial. We need to keep sensitive information like passwords and API keys safe by using dedicated services designed for that purpose. Regularly rotating secrets and following the principle of least privilege access are key best practices to keep everything secure. Okay, let's talk about zero trust. Traditionally, security was like a castle wall. If you got inside, you were pretty much free. But in today's world, things are different. We're working from anywhere, using all sorts of devices. Zero trust flips that thinking on its head. It basically says, never trust, always verify. It's built around the idea that every asterisk user and device needs to be checked continuously even if they've already logged in. We use techniques like micro-segmentation, which breaks down applications into smaller, secure areas, and always require multiple forms of authentication. And, crucially, we only give people access to what they absolutely need for their job. It's about building a system where security is baked in at every step. Okay, let's talk about keeping your applications safe with tokens. A key focus for any application security engineer is managing these digital keys. First and foremost, always use short-lived tokens. The shorter their lifespan, the less time an attacker has to exploit them. We also need refresh tokens, which allow users to get new access without needing to log in again, but the asterisk must be stored very securely. Then, there's token revocation. If a user leaves or something looks suspicious, you need to be able to invalidate their token immediately. Secure storage is vital too. Think about using tools like Vault or AWS Secrets Manager rather than just embedding tokens directly into your code. Finally, remember to always check the expiration date and what permissions the token actually has before letting it access anything. Okay, let's talk about logging and how it ties into your SIEM. Think of logging as creating a detailed record of everything happening within your application, who's doing what, when, and where. It's not just about errors. We want to capture key user actions, access attempts, and any unusual behavior. Then, a security information and event management system, or SIEM, is like your security command center. It pulls together all those logs from different parts of your application and looks for patterns that might indicate a problem. A SIEM helps you normalize the data, set up alerts when something suspicious happens, and generate reports to show how secure things are. Okay, let's talk about database security. It's a really important piece of the puzzle when you're building applications. Think of databases as holding all your valuable data, making them an attractive target for hackers. There are several common vulnerabilities we need to watch out for. Things like SQL injection, where attackers can manipulate your queries just by entering malicious input. We also have other injection attacks and issues with weak passwords or permissions. But the good news is there are plenty of ways to protect your databases. Using parameterized queries, often called prepared statements, is a fantastic first step because it separates user input from code. Then, validating and sanitizing all the data that comes in helps prevent problems. And finally, Always follow the principle of least privilege, only give users and applications the access they absolutely need. Okay, so let's talk about keeping user information safe. We often use something called sessions to remember who's logged in. A session ID is like a secret key that the website gives you. It's stored on your computer and used to find all the details about your login. But there are risks involved. If someone steals that key, they could take over your account. A more modern approach is using access tokens, which are kind of like digital certificates. They are digitally signed, meaning they can be verified, and they don't require the website to keep track of everything on its site. It's a stateless system, making it much more secure and easier to use across different applications. Okay, let's talk about two really important threats for application security engineers: command injection and deserialization attacks. Command injection happens when an application takes user input, like something you type into a form, and directly uses it in a shell command to be executed on the server. Imagine someone injecting malicious code into that input. They could potentially gain complete control of your system. The good news is there are ways to prevent this, mainly through careful input validation and escaping. Now, deserialization attacks are a bit trickier. They involve taking data from an external source, maybe another user or website, and then converting it back into an object within your application using functions like PHP unserialize. If you don't properly check the data, attackers can inject malicious objects that could cause serious problems for your application. Okay, let's talk about how to keep your applications secure while leveraging the awesome benefits of caching and CDN. These technologies are fantastic for speed and availability, but they can also introduce some security risks if not handled properly. We'll cover some key dangers like cache poisoning, where attackers might try to inject malicious data into the cache, and then dive into how you can protect your applications using techniques like sign URL, strict HTTPS enforcement, and smart caching and validation strategies. It's really important to integrate WAF with your CDN too. Think of it as adding an extra layer of defense. Security is a continuous effort, so stay informed about the latest threats and best practices. Let's talk about a critical area of application security: how we handle data coming in from outside our systems. Specifically, we're focusing on file and data deserialization. Think of it like this: an app receives some information, maybe it's a user uploaded image or a form submission. It then needs to take the information and turn it back into something usable, essentially rebuilding an object. This process is called deserialization. Now here's the tricky part: attackers can craft malicious data in a way that tricks our app into executing their code during this reconstruction phase. It's like giving someone the instructions to build your computer from scratch. If those instructions are bad, they could cause serious problems. Java serialization, PHP unserialize, and even Python's pickle can be exploited. The good news is there are ways to protect ourselves. We can often avoid deserialization altogether by using simpler formats like JSON or protocol buffers. If we do need to use it, rigorous input validation and sanitization are key, along with choosing safe serialization libraries and disabling the feature when it's not necessary. Understanding these vulnerabilities and our mitigation strategies is crucial for building secure applications. Okay, let's talk about memory management, a really important area of application security. Today's slide focuses on two common problems: buffer overflows and memory leaks. A buffer overflow basically means you're writing more data into memory space than it can hold, like trying to stuff too much into a box. This can mess up your program or even let attackers sneak in malicious code. Then there are memory leaks. Think of them as holes in your memory budget. Your application keeps asking for more and more memory but never gives any back. Over time, this can really slow things down or even crash the whole system. It's vital to write clean, careful code and use tools that can help spot these issues before they become serious problems. Let's talk about how we measure our success in application security. We use KPI, key performance indicators, which are really important numbers that show us where we're doing well and where we need to improve. For example, we track how long it takes to fix vulnerabilities, or how quickly we spot security issues once they arise. These metrics help us understand the efficiency of our team. We also look at things like code coverage by scanning tools, aiming for around 80% or higher, and keeping an eye on false positives. Those are alerts that aren't real threats, so minimizing them is key to avoiding wasted time. Finally, we monitor compliance with standards like the OWASP Top 10, ensuring we're following best practices. Okay, let's talk about threat intelligence feeds. They are absolutely essential for any AppSec engineer. Basically, these feeds are like early warning systems for the digital world. There are different kinds. You've got commercial feeds that offer really good, curated data, often including those super rare zero-day vulnerabilities. Then there are open source options which can be great but require a bit more work to sift through. And finally, sometimes industry-specific feeds will give you even more targeted insights related to your particular field. The important thing is to get these feeds working in your security tools, think seams and scanners, and then focus on the alerts that actually matter for your asterisk apps. Okay, let's talk about keeping our applications secure. Specifically, we're focusing on CV and security advisories. Those are like little warning signs for potential weaknesses in the software we use. A CVE is essentially a unique ID that identifies a known vulnerability, and a security advisory tells us all the important details about it, including what it means and how to fix it. It's vital that we actively monitor for these vulnerabilities using tools like scanners and by keeping up to date with threat intelligence feeds. Then, we need to prioritize. Not every vulnerability is equally dangerous. We'll look at things like the severity score and whether there's a way to actually exploit it, as well as how important that specific application or component is to our business. Let's talk about application security playbooks. Think of them as detailed, step-by-step guides that help security teams tackle common vulnerabilities in apps. It all starts with understanding the potential risks. We use things like Stride to map out what could go wrong. Then you create specific playbooks for each threat, detailing exactly how to find, analyze, and fix it. Automation is key here. Tools can speed up the process massively. And finally, don't forget to keep these playbooks up to date as threats change. Security is a continuous cycle. Okay, let's talk about how application security engineers are assessed in interviews. A big part of the process involves looking at realistic scenarios and case studies. You'll likely encounter questions around common vulnerabilities like SQL injection or cross-site scripting, things you've probably heard about in the OWASP Top 10. They might also present a system design and ask you to find weaknesses or how to secure it properly. The key is not just knowing the answers, but being able to articulate why something's vulnerable and what steps would make it more secure. Okay, let's talk about security patch management, a really important part of being an application security engineer. It's not just blindly installing updates, it's about actively managing risks. First, you need to find out what vulnerabilities exist in your apps and systems. Vulnerability scanners are your best friend here. Then, you have to prioritize those vulnerabilities based on how serious they are and how likely they are to be exploited. After that, testing is vital. Make sure the fix actually works before you push it live. And finally, always monitor your applications after deploying patches to ensure everything's running smoothly. Okay, let's talk about how we actually find vulnerabilities in applications. Manual code reviews are great, but they are incredibly time-consuming and prone to human error. That's where security automation tools come in. We have a few key players: Checkmarx, Veracode, and SonarQube. Checkmarx is a SaaS tool that looks at your source code itself and flags potential problems like SQL injection or cross-site scripting before the code even runs. Then we've got Veracode, which is a DaaS platform. Think of it as simulating an attack against a live application to see if any weaknesses exist that can be exploited. Finally, SonarQube provides continuous inspection throughout your development process, catching issues early and integrating seamlessly into your CI/CD pipeline. These tools aren't replacements for skilled security engineers, they're powerful assistants that help us find problems faster and more thoroughly. Okay, let's talk about how Red Team actually tests an application. Think of it like this: we're trying to break in, just like a real attacker would. We use different approaches. Black box testing is when we go in blind, using only what the user sees and interacting with the app as they would. Grey box testing gives us a little bit more information, like maybe some documentation or access logs, which helps us focus our efforts. And then there's white box testing, where we have full access to everything: code, diagrams, even credentials. Finally, fuzzing is a really cool technique where we just throw random and weird data at the app to see if it breaks or reveals any hidden weaknesses. Okay, let's talk about making your code secure from the start, specifically how we use code linting and secure coding standards. Code linting is like having a really detailed proofreader for your code, automatically checking it for common mistakes and ensuring it follows consistent style guidelines. Tools like ESLint and SolarLint are super helpful here. But beyond just making things look nice, we also need to follow secure coding standards. These aren't just stylistic preferences, they're rules designed to actively prevent security vulnerabilities. The OWASP Top 10 is a great resource for understanding these risks, and the secure development lifecycle emphasizes that security needs to be part of every stage of development, not just an afterthought. Okay, so let's talk about where your application's data actually lives. We're focusing on two really important concepts: data residency and localization. Data residency is basically the legal requirement that certain types of information like customer details or financial records need to be stored within a specific country or region. Think of it as keeping your data at home. Localization, on the other hand, is much broader. It's not just about translating the app into different languages, it's about adapting everything from the user interface and content to how you handle things like data formats to fit the cultural norms and legal rules of a particular area. There are lots of regulations out there that dictate this, like GDPR in Europe, which has very strict rules about how data is processed and moved around. And then there's CCPA/CPRA in California and PITE in Canada. It's important to be aware of these laws and industry-specific regulations too, so you can build applications that are compliant and successful everywhere they're used. Okay, let's talk about getting security right from the start. When you're an application security engineer, it's not enough to just bolt security onto a finished product. Instead, we need to think ahead and build security requirements into the software development lifecycle at SDLC. This means working closely with everyone involved in creating the app, from the people who define what it does all the way down to the developers building it. We use things like threat modeling, which helps us anticipate potential attacks, and we make sure we're keeping an eye on regulations and compliance too. Basically, the earlier you identify security needs, the better protected your application will be. Okay, let's talk about securing those backend API that power your mobile apps. They're a really important battleground. First, we need rock-solid authentication. That means verifying who the user really is, and using multi-factor authentication whenever you can. Then, it's all about controlling what users can do with their access, the principle of least privilege. Next up, rigorously validating every single piece of data coming from the app, no exceptions. And finally, designing your API securely from the beginning. Use HTTPS, limit request rates to stop abuse, and encode output to prevent those nasty XSS attacks. Okay, let's talk about hardening OAuth and OIDC integrations. They're super important for protecting your applications. Basically, we want to make it really difficult for attackers to impersonate users or steal tokens. The first thing we should focus on is strong authentication. MFA is a great way to add an extra layer of security. Then, always rotate client ID and secrets regularly, don't leave them sitting around. Scope management is also key, only ask for the permissions you absolutely need. On the server side, it's vital to validate tokens thoroughly, checking things like expiration dates and whether they've been revoked. And finally, securely store those client secrets, ideally using something like an HSM or a key vault. Rate limiting can also help prevent brute force attacks. Okay, let's talk about keeping our apps safe by managing open source components. It's really important because these libraries are everywhere. We have a few key tools to help us. Snag is fantastic for automatically scanning your code and finding vulnerabilities in the packages you're using. It even tells you how to fix them. Then there's Dependabot from GitHub. It's like an automated security alert system that proactively updates those vulnerable dependencies for you with pull requests. And finally, White Source gives us a really comprehensive view of all our open source licenses and vulnerabilities, which is super helpful for staying compliant. Think of these tools as your security team's eyes and ears when it comes to open source. Okay, so Agile and DevOps have completely changed how we build software. It's all about speed and teamwork. But if we're not careful, security can get pushed to the back burner. The key is shifting left, which means bringing security into the process *earlier *on, right from the start. It's no longer a separate phase. Instead, we need to consider potential vulnerabilities as part of every stage: planning, designing, and building. We're talking about things like threat modeling, figuring out what could go wrong before it does, and using tools that automatically scan our code for problems or test the running application. Plus, securing our infrastructure itself is super important too, which is why we're looking at infrastructure as code scanning. Having a DevSecOps champion within each team really helps drive these changes forward. Let's talk about SSRF, server-side request forgery. It's a sneaky vulnerability where an attacker can trick your server into making requests to places it shouldn't. Essentially, they're using the server as a proxy to access internal systems or even external services. The key is to carefully validate any input that might be used to construct URL. Think of it like building with Lego bricks. Only use blocks you know are safe and fit together correctly. Whitelisting allowed domains and protocols is super important, but don't just rely on blacklists, they are often bypassed. Finally, good network segmentation and firewalls can add an extra layer of protection. Okay, let's talk about securing your API with cryptography. First off, it's crucial to use strong algorithms. Things like SH-256 and AES are much better choices than older methods. Next, you need a solid key management strategy. Think HSM for storing keys safely, and regular rotation is super important. And finally, don't just rely on cryptography alone. Integrate it with authentication and authorization protocols like JWT and IOAuth 2.0 to make sure only authorized users can access your data. Okay, let's talk about designing API securely. Think of your API as the doorway to your application. You want to make sure only authorized people can get through. We'll cover some really important patterns that help us do just that. First off, always validate and sanitize any input you receive, whether it's from a user, another service, or even a third party. This prevents things like SQL injection attacks and cross-site scripting. Then, rate limiting is key to stopping brute force attempts. Next, secure your authentication and authorization, making sure users are who they say they are and only accessing what they need. Output encoding, make sure the data you send back doesn't cause problems on the client side. Finally, remember the principle of least privilege. Give an endpoint only the permissions it absolutely needs to do its job. Security starts with good design. Let's talk about how we document and visualize our work as application security engineers. Good security starts with clear communication, and that begins with robust documentation. We need to outline exactly what security features we're aiming for in a security requirements specification, essentially defining the rules of the game. Then, a threat model is vital. It helps us proactively identify potential problems before they become actual vulnerabilities. We also have a vulnerability management plan, detailing how we'll find, assess, and fix those issues. And finally, secure code review guidelines ensure everyone's on the same page regarding best practices when writing code. Beyond documentation, diagrams are incredibly powerful. Attack paths map out possible attack routes through an application, helping us understand where to focus our defenses. Data flow diagrams show how sensitive information moves around, and system architecture diagrams give a high-level view of the entire security setup. Documentation isn't just for audits, it's truly essential for building secure applications from the ground up. Thank you for watching.